Okay, everybody, this is Mr. Hinnon again at the Hinstitute. I'm going to try something new. A lot of people have been having difficulty with the right hand rule. So what I have done is I know it's our right hand. So our index finger is in the direction of the velocity. Our middle finger here is the direction of the magnetic field, and our thumb points in the direction of the force. So what I did is I took a wire coat hanger here and I actually created that same thing. So there's my index finger, there's my magnetic field, and there's my thumb. So if you can kind of see it, that's my three-dimensional setup so that I can kind of show you what's going on. So with the right-hand rule problems, one of the problems looked like this. And the idea is you were supposed to figure out what direction the magnetic field would have in these four different sections, 1, 2, 3, and 4. However, it is a negative charge. I'm going to do it with being a positive charge and basically just change it when it becomes a negative charge. So if I use my actual right hand, the idea is I would send my particle moving in this direction. So I'm moving my finger in the direction of the field, of the velocity of it, and then I need it to move to the right. So that means I need my thumb to point towards the right to cause it to turn in that direction. And if that happens, then my magnetic field would be pointed up out of the paper at number 1. So I can do that with my little object here. So if it's moving in this direction, but I need it to be pushed to the right, then I need that magnetic field to be pointed up. But this is for a positive particle. In this example, it has a negative particle. So that can't work like that. Basically, I need to reverse that direction. So if a positive particle would feel it with a magnetic field pointed up, and that would cause it to move this direction, then a negative particle would actually want it to be downward. The only way I can really do that is one of two different ways. Either just realize it's the opposite of my right hand, or I've sometimes mentioned that you can actually switch over to your left hand. Your left hand rule would be this direction. If I need a force to be to the right to push it this way from 1 into 2, then my magnetic field would be down. It'd be into the paper. Then when it gets up here to number 2, it's moving in this direction, but I need it to turn to the left. So I need that force to actually now be to the left. So now in 2, the magnetic field is going to be up. And that's if it's a negative charge, use the left-hand rule, left, or positive charge, use the right-hand rule. Now the other one that we had difficulty with was this one over here. And this one involved two different circles and trying to figure out whether it was an electron or a proton and whether it was going clockwise or counterclockwise. So the best way I can kind of go after this one, in this particular case, the magnetic field is down into the paper. So if it's into the paper, that means that our magnetic field is pointed downward. What I need is I need the force to actually be toward the center of this paper, or towards the center to actually get it to move around in a circle. So if I have my particle right here and it's moving upward and the magnetic field is down, it's into the paper, then if I'm on the right side of this circle and I have a force that's toward the center, that's my little contraption here, then the one on the right is going to actually be a positive particle. I'm going to do this with my actual finger. I think it might be a little bit better. So if I had the particle moving in this direction, but the magnetic field was down, so it's pointed towards the paper, then my force is going to be toward the center of this, and that's going to cause this particle to turn, and it's going to be moving this way. And if I am moving this way around this circle, I am actually going counterclockwise around this circle. If I'm on the other circle and I do the exact same thing, I would be going counterclockwise here. If I was a negative particle, however, then I would use my left-hand rule, and I would be moving, if it's, let's say on the left side, I need a force towards the center when the magnetic field is down. That would cause my particle to move clockwise around this. So if in either one of these cases, if it was clockwise, it'd be a negative particle. I would highly suggest, if you can't really understand how to do this with the right hand, then make some kind of contraption. A wire hanger worked really well for kind of following things along and seeing what was going on, as long as you can kind of create it. I think you could probably even modify that to work with a current. So instead of talking about the index finger being the velocity, that would be the direction of the current that would be acting on this thing. The middle finger would still be your magnetic field. If you were talking about a torque, which is the latest thing we've been talking about, what we actually have is the cross product between a thing called the magnetic moment, which is the number of turns times the current times the area. And that would be the direction of this, the magnetic moment would be the index finger. And that's actually the direction of the surface. So if my paper here, I'm going to flip this paper over. If this was my paper, the surface would actually be pointed straight up from it. So if this was my area that I had actually creating a magnetic field in. So let's say this was a loop of wire. Actually, I can just use the other side. Let's say this is a loop of wire instead. The magnetic field, or not the magnetic field, sorry, the magnetic moment would actually be straight up from the paper. That would be the direction of the magnetic moment. And so I would point my finger there, and then if I had some magnetic field on it, then this over here would actually give me, the thumb wouldn't give me a force this time, it would actually give me a torque. But that's just an extension of this, and we'll work more with that later. My hope is to try to teach you as much about magnetic fields as I possibly can. I hope this little video helped a little bit, because I know a lot of people have been having difficulty with magnetic fields and the right-hand rule. So this is just another edition of the Hinstitute, and I look forward to giving you more lessons as time progresses. Take care, be well.